Okay, this is the last video on a three-part video on how to describe the motion of a kinematics graph. So let us just recap on what we have learned so far. Basically, in the first two videos, we have been talking about the basics of gradient. And if you have not viewed any of this video, it will be good that you can view the first two videos. But if you are already very skillful in the understanding of gradient, then you can proceed directly to this last video, which is highlighted in red, which is to describe the motion of the kinematics graph using the information about the gradient. So first of all, let us recap about the gradient. If you see a horizontal line running in this direction, obviously the gradient is 0. If you see a vertical line that's running upwards, it will be infinite gradient. If you see a straight line that's pointing top right, okay, it means top right represent positive, straight line represent constant, so it's positive constant gradient. And if you see the line pointing bottom right, it is negative constant gradient. So next, if you have again these two graphs, they are pointing top right, but this one, the gradient is going from gentle to steep, so it's positive increasing gradient, gentle to steep and pointing top right. This is pointing top right, but it's steep to gentle, so it's positive decreasing gradient. This is pointing bottom right, so it's negative, and it's going from gentle to steep, so it's going to be negative increasing gradient. And finally, this is also pointing bottom right, so it's going from steep to gentle, so it's negative decreasing gradient. Now, how do you describe the motion after knowing about the gradient? Basically, it's the replacement of one single word. Now, in distance time graph, the gradient represents the speed. So in other words, if you look at this graph without knowing that it represents distance time graph, you will simply say that the gradient is positive constant gradient. Now, the only difference between describing motion and describing the gradient is that you replace the word gradient with speed in this case, in the case of a distance time graph. But of course, speed is a scalar quantity. You don't need to write the positive. You can just say constant speed. So the answer is simply constant speed. Alright, because speed will always be positive. Now, for displacement time graph, the gradient represents the velocity, and once again we know that this is a positive constant gradient, so you replace the word gradient with velocity, you get positive constant velocity. So it's that simple. So if you have that very good grasp of interpreting the gradient, then you just need to remember that what does distance time graph represent, what does displacement time graph represent, and just by replacing that gradient with what it represents, then you can describe the motion. It's that simple. So let's move on. Now, what about speed and velocity? Same thing, alright? In the speed time graph, the gradient represents the acceleration, and you know that this is positive constant gradient, so it's going to be positive constant or constant positive acceleration. Similarly, for velocity time graph, the gradient represents acceleration, so it will be constant positive acceleration or positive constant acceleration. Alright? So with this understanding, now let us just look at two examples. Let us look at displacement time graph, and later we will look at velocity time graph. So remember that displacement time graph, the gradient represents the velocity. So if you know that, let's say this is a horizontal line, it represents a 0 gradient, it's simply replacing the word gradient with velocity. So it's going to be 0 velocity, which doesn't sound very elegant if you say that. So the best way to say is just simply put it at rest. Now for infinite gradient, obviously it means infinite velocity. But infinite velocity doesn't exist in physics because you can't go faster than light. So obviously it is not possible. So we don't have to talk about that. So how about the third one, positive constant gradient. So once again, you replace the word gradient with velocity, you get positive constant velocity. That is how you describe motion. And lastly, negative constant gradient, you get negative constant velocity. Simple as that. Okay, so let's use curve now, and at the same time let's use velocity time graph to describe motion. Okay, so if let's say we are given a velocity time graph, and this is you must remember what the gradient represents. The gradient represents the acceleration. So once again, we know that this is a positive increasing gradient, so you just replace the word gradient with acceleration, so you get positive increasing acceleration. So the second one is positive decreasing acceleration. Third one is negative increasing acceleration, and last one is negative decreasing acceleration. So you realize that the concept of gradient is very, very important to describe motion. If the concept of gradient is not strong, or it is not applied in the description of motion, you will need a lot more understanding to describe the motion. But by using this technique, you can describe the motion of a kinematics graph better. Okay, so this is the last part. This is the last video on a 3-part video on describing motion. This is by no means the end of the lesson that I'm going to give on describing motion. I may give another lesson on a common misconception about describing motion, as well as some techniques that can further improve your method of describing motion. So do check out any future videos that I'm going to produce. It will come soon. Okay, thank you very much and have a nice day.